Welcome back to the crash course, The Reliability of Defective Information in the Sciences. This video contains a brief summary of what has been discussed in the first half of the course. Particularly, here we sketch the grounds of the rational tolerance of defective information in scientific contexts. This video will provide us with a description of the first part of the epistemic landscape of behind the reliance on defective data in the sciences, focusing mostly on ignorance and its relation towards the rational toleration of these defects. Before doing so, please remember three main points. First, defective information is an umbrella term that covers cases of partial, vague, incomplete, conflicting, and inconsistent data. Second, in spite of the fact that defective information is often considered to be unreliable, in the sciences, scientific information is actually often defective, and the defective character of scientific data is not only common but inevitable. Third, one of the main motivations behind the study of defective information in the sciences is that the way in which we, as human agents, respond, deal with, and solve challenges such as contradictions, vagueness, partiality, among others, can be actually revealing about the constraints of human rationality. In light of this, the aim of this first half of the course is to provide you with a general philosophical toolbox for the analysis and explanation of those cases in which scientists use, and sometimes even rely on, defective sets of data and their practice still remain rational. Now, let's move to the toleration of defective information. This is a phenomenon which takes place once agents identify a particular defect associated with a relevant part of the reasoning, their theory, their model, set of data, etc. But they are still able to do two main things. First, to reason with or from this defective information to reach interesting or novel conclusions, as well as to distinguish between the inferential products of the reasoning that are sensible given a particular context from those that are not. This is often called the preservation of sensible reasoning. Now, the first step in the road to the rational toleration of defective information is detection. Even if all the time the information that we have is naturally defective, at least in the sense of being incomplete and partial due to our cognitive and physical limitations, and even if we are very much familiarized with the idea that we, for instance, know less than the amount of things that we ignore, there are cases in which incompleteness of data becomes a present scientific issue. For instance, when we lack enough details of the requirements for the building and evaluation of a particular experiment, or when our theoretical frameworks exhibit problematic explanatory or predictive gaps, among others. For the case of inconsistency, there are also many scenarios in which contradictions are not problematic at all, and we are fine with finding them. For instance, when having rival theories that contradict each other. In those cases, the mutually conflicting character of the involved theories is seen as an organic component of the rivalry. However, the really problematic presence of contradictions takes place whenever either two mutually inconsistent theories or models are expected to be used together in the same domain of application, or when a theory contains two mutually inconsistent statements, or a practice requires two mutually inconsistent instructions, or when the theory's predictions contradict irremediably the scientific observations of the particular phenomena that is relevant at the moment. Once a scientist recognizes the defective character of a set of information, meaning incompleteness or inconsistency, she can either reject such a set or keep working with it. Those are the only two options. If doing the former, meaning rejection, she would need to explain why she dismissed it. So this information was there not for no reason, but it has a backup justification. So if you want to reject it, then you have to provide a robust explanation of why you now don't need it, or it came from an illegitimate source, or something like that. If choosing the latter, meaning working with or from this information, she would need to identify inferential mechanisms that allow her to work with defective data and still avoid logical and epistemological challenges associated traditionally to the use of defective information. When succeeding at doing this, meaning providing explanations of how they infer from from or with this information, the result is usually called the rational toleration of defective data. Now, in order to explain either the mechanisms that might underlie the use of defective information or to justify the rejection of sets of defective data, it is necessary to shed light on the grounds of these defects. This is, where are they coming from? A common answer to this question is ignorance. For instance, take the case of the generic explanation that is provided to justify cases of inconsistency toleration in the sciences. This explanation goes as follows. First, when having two scientific statements that contradict each other, scientists tend to assume that at least one of them is false. This is more or less a very intuitive reaction once we realize that we have a contradiction in our hands. If scientists are able to distinguish which of the conflicting propositions should be regarded as false, then they would be able to explain how they could satisfactorily work on seemingly false information. However, most of the time, when confronted with an inconsistent set of information, scientists ignore at least which of the mutually contradictory statements should be regarded as false. Once this ignorance is acknowledged, if scientists have no better alternative to the inconsistent set of propositions, the toleration of the contradictions becomes the only option. Such a tolerant attitude towards contradictions and other defects is often seen as only temporary but very rational measure. The common agreement on this connection is that ignorance plays an important role in motivating scientists' tolerant attitude towards certain contradictions, but that it is constitutive as well of the temporary character of such toleration, meaning that while ignorance can provide us with a justification of why we have defective information in our hands at the moment, it's also saying that we have to get more information or we have to search for more data in order to solve these defects or get rid of the conflicting statements and so on and so forth. Now, the question is how do we understand ignorance, and especially the ignorance involved in the presence and toleration of defective data? Looking at the literature, we would be able to see that traditionally, ignorance has been understood as lack of knowledge. In this sense, one can be ignorant via the non-satisfaction of any of the basic conditions for knowledge. This is by fulfilling a doxastic condition, meaning believing that P, failing at fulfilling the dialectic condition, determining the truth value of P being true, failing at satisfying the justificatory condition, believing that P with justification, or any of the versions of Gettier proof conditions. So, taking this into account, we can move forward to think about the types of ignorance that we can find in the sciences. And if actually ignorance can be understood as absence of knowledge, then we can see which are the types of knowledge that we might find useful in science and see how their absence might affect the scientific practice. So first of all, there is factual knowledge, meaning knowledge about facts. Either something is the case or not is the case. This can be translated in knowing a particular fact or knowing the truth value of a particular sentence. So when we ignore this ignorance conflicts with scientific reasoning by limiting the applicability of certain inferential rules. Because then we cannot move forward if we don't know whether something is the case within a theory or within a model to say which are going to be the reliable consequences of that being the case. Now, another type of knowledge that we might find useful is objectual knowledge, meaning knowing objects, persons, places, things. This means not only knowing facts or the truth value of particular statements, but knowing how lists of properties and descriptions may relate to one another in order to provide us with a more or less adequate description of what a person is, of what an object is, and so on. And so when we are ignorant in this sense, that prevents us from connecting lists of properties to a particular object. So we might have a lot of data that we cannot integrate and put together in order to get a better grasp of what is the phenomenon that we are dealing with. Now, the case of procedural knowledge. Procedural knowledge has two main versions. So one is us being able to provide list of instructions or steps that we should follow in order to move from one point to another. And the second version is us being able to do it even if we cannot provide an explicit list of how we are doing it. The first case is often illustrated by a matter of looking at cooking recipes, for instance. If a chef is a really good chef and writes a book, then if you follow precisely each instruction, the dish is going to come out very nice. And that exhibits that that person has enough procedural knowledge to guide you in the preparation of a particular dish. A case of procedural knowledge in which people cannot really explain what happens is, for instance, us riding a bike or us calming a baby who is crying. So we might not be able to provide an explicit list of which step is followed by the other, or which is the secret ingredient that we add in order to get to the successful task. But anyway, we are still able to perform this task in many different scenarios. So that exhibits that we know the procedure associated to either calming a baby or riding a bike. And what happens when we lack of this procedural knowledge? The ignorance associated, which is going to be procedural ignorance, conflicts with scientific practice, especially in experimental contexts. For instance, consider a scenario in which the members of a particular scientific community are ignorant of how to reproduce an experiment in order to validate the other team's reports. This absence of procedural knowledge will become an impediment for the other team's results. Now, there is a final case of knowledge that I would like to discuss for this particular issue, which is knowledge of theoretical structure. A knowledge of theoretical structure, especially ignorance of theoretical structure, is lacking knowledge of the relevant inference patterns that scientific theories allow for. When ignoring the relevant parts of the theoretical structure of a theory, scientists are not able to grasp abstract causal connections between the propositions of their theory. So it's not only that they don't know the truth values, they don't actually can see how each element of the theory connect to the others. They can either identify the logical consequences of the propositions that they are working with, nor can explain under which circumstances the truth value of such propositions will be false. This is what I like to call ignorance of theoretical structure. And if you look at the general description of which are the effects of this type of ignorance, we are going to be able to see that they have a direct ignorance of theoretical structure has a direct impact on the emergence of factual ignorance, for instance. It's one of the consequences that you cannot determine which is the truth value of the propositions that you are working with. You can also see that it will have an effect on procedural ignorance. So you might ignore how certain steps, inferential steps, can be followed, but this might be associated with the fact that you actually don't have a grasp of the structural constraints of the theory or the model or the part of the description that you are working with. Now, the road to toleration, once we have said these things about ignorance, we have to go back to the toleration of defective information. Now, the road to toleration starts with scientists discovering the connection between the defective information and the factual ignorance. So what happens is that often, in both types of cases, incompleteness and inconsistency, scientists lack precise knowledge about the data sets, and this obviously has an impact in recognizing the incompleteness of the data. So I don't have enough data to be able to see how these things relate to one another. I don't have enough information to decide whether this proposition is true or false, etc. But also, it also generates, in particular cases, the emergence of contradictions. As I was saying, one of the main options, of the most intuitive options that we have when dealing with when identifying a contradiction, is to say that one of the components is false. But if we don't have enough information to decide which one is false, then we are stuck with a contradiction that we cannot dissolve. And so the path that one can follow is the following. So we have actual ignorance, we recognize that, we still need more information to know whether something is the case or not. And then we either have a consistent alternative, and then we don't have to deal with this, or a more precise alternative, in a sense, more virtuous alternative, or we have to tolerate it. But this is not enough for toleration, as I have been mentioning. So we only are motivated for having a tolerant attitude towards the defect. Now, what is the next step? The next step is the selection of inference patterns. And these inference patterns can be as traditionally or classical preserving as possible, or a bit more open to the defects. So in the cases of contradictions, you might find paths that are associated to consistency preservation, such as compartmentalization. We might have something that looks like a contradiction, but we part it into, we don't relate information from one bit to the other, and then we have like really two different issues. And there is a sense in which the contradiction doesn't emerge because we are never putting them together. We can also have cases of information restriction. When you do this type of compartmentalization, what you are saying is information that is associated to A is not going to be mixed with the information that is caused by not A. And so these are consistency preserving mechanisms, because in the long run, what they are going to aim at is to show you that consistency is the strongest constraint that allows you for preserving sensible reasoning in this context. But now, you can also have more flexible mechanisms, which are going to be, for the case of contradictions, inconsistency toleration type. Some of them can be characterized as a consistent compartmentalization, which are going to allow you to mix a bit of the information that is resulting from A with the information that is resulting from not A, without reaching triviality or logical explosion. But you also might have a stronger version of this, which is going to be dialecticism, according to which it is okay to have contradictions, meaning information looks inconsistent, put it back together, and still being able to reason with it, because those contradictions are special, and they are actually true, both statements. So in that sense, dialecticism is a type of theory that will allow us to find inconsistency tolerant, strong inconsistency tolerant mechanisms to explain why we can work with this defective data. Once we choose any of these patterns and we explore it on our particular case, and we realize that this type of inferential pattern actually helps us to work with information without multiplying the mistakes or the defects that we have, then we start overcoming the ignorance of theoretical structure, because now we have shed light on the particular bits of the inferential connections that allow us to contain the problem, as well as to move within the theory in a satisfactory way. And this is what we call partial overcoming of ignorance of theoretical structure. The partial overcoming of ignorance of theoretical structure is actually what backups the rationality behind the toleration of defective data. So as soon as we can build an explanation that involves the identification of our ignorance, the way in which this ignorance justifies our tolerant attitude towards the defect, and then the selection of the type of inference patterns that rule and constrain this defect in order for us to still draw sensible conclusions and so on, then we have an explanation for our toleration of defective data. Now, if we look at the literature, there are going to be two types of explanations of this character. Some are going to focus on the epistemic or doxastic elements, and some others are going to focus on the logical elements. If you want to know more about this, you are going to find some references in the previous video that appeals to the three types of programs researching this. But so, very briefly, the ones that focus on epistemology are going to tell us a story about how we, for instance, in the case of compartmentalization, we pull apart our beliefs. And sometimes we think that something is true, A, for instance, and we assume that not A is not true, or even that is false, but we still use it as soon as we don't combine it. So we do a doxastic compartmentalization, but we also are doing a doxastic weakening. We are weakening our commitments towards the negation of A, while keeping the strong commitments towards A. And so the main explanation in this case is that we never believe that A and not A are true at the same time, because we don't believe that A and not A are both true. We have an explanation for why we have not A. It's the result of an idealization, an abstraction, and a fiction. And we also have an explanation of why it is useful. So we look at the literature on fictions, idealizations, simplifications, abstractions, and we provide an explanation of why it can be useful. Now, we focus on the particular case, and then by highlighting the inference patterns, we can also explain why it was useful in this particular context, and under which circumstances it was safely useful. So that is the case of the epistemic programs. Now, if we are tackling the same example from a logical perspective, we are going to find a very similar strategy. In the large majority of cases, we have different types of fragmentation. And in these cases, what we are doing is we are developing strategies that allow us to say, oh, these two bits of information, even mutually contradictory, are not mixed together in an explosive way. Either we take a paraconsistent logic, or we take paraconsistent reasoning strategies, or any other formal resources that can help us to track how we relate inconsistent information in such a way that we are not producing more contradictions, we are not reaching logical triviality, and still we are going to be able to preserve sensible reason. But as I was saying, in many of these cases, the mechanism is very similar to the one in epistemology: fragmentation, compartmentalization, or restriction of information. Now, that said, we have, just to recap, we have in this video provided part of the landscape associated to the rational use of defective data in the sciences. We have addressed the issue of ignorance and how it relates to the rationality behind the toleration of defective information. Now, in a recap, if the toleration of defective information is actually rational practices, philosophers, historians, sociologists of science should explain the following. First, under which circumstances scientists would be rationally inclined to tolerate a defect within their theory, model, and set of data. And second, how they could preserve sensible reasoning when using defective information. So, well, ignorance will help us to explain the first part. Inferential patterns and the detection of them will help us to explain the second part. In this video, we explain how these explanations appeal to ignorance, but beyond that, by shedding light on the inferential patterns that are involved in the handling of defective data. So, as we have been saying all along, if we want to explain satisfactorily the rationality behind inconsistency toleration, partiality toleration, incompleteness toleration, among others, then we have to combine an explanation, we have to combine approaches from epistemology appealing to ignorance, as well as from logic appealing to the inferential patterns that we followed along. This shows that the toleration of defective information is an epistemic as well as a logical phenomenon, meaning that both components are equally important when providing explanations for the rationality behind working with defective data. That said, thank you very much, and see you in the next video. If you have any comments or questions, just write them below the video, and see you soon.